Hello, my name is John Bozard, and this is my Physics 2212 Lab 1 on charged tapes. The goal of this lab is to create a computational model through Glossgroup that calculates the charge of one piece of tape and the magnitudes of the electric and gravitational forces on the floating tape. For this experiment, we are to assume that the two tapes have the same charge and that they are conceptually point charges. Also, air resistance is ignored, so the only two forces on tape B are gravity and the electric force caused by tape A. The net force in the y direction is 0, so Fe on B by A is equal to F grav. Additionally, on the right is a simplified free body diagram in which two charged tapes labeled A and B are repelled from each other. As a result, the bottom tape experiences an electric force from the floating tape B in the negative y direction. Important physics concepts implemented in this lab include Newton's second law, where F equals ma, the force of gravity, Fg equals mass times acceleration due to gravity times direction vector j hat, Coulomb's law, which determines the electric force between two charges, and lastly, the force found from multiplying the charge of a point by the electric field of the source value. The initial tape statistics, such as length, mass, and width, can be seen in the top left. After I charged both tapes, I followed the procedure shown in the picture to determine a distance of 2.8 centimeters. I found that the two tape charges are positive because they repel each other and are attracted to a negatively charged plastic pen. The force of gravity on tape B is found to be negative 1.862 times 10 to the negative third newtons. Because F net equals 0 and Fg plus electric force equals 0, the two forces have the same magnitude. Using the electric force equation from the previous slide, I set the calculated Fg value equal to Q times the electric field and solved for the charge of tape B. The excess electrons on tape B can be found by dividing the tape's charge by an electron's charge. This value is 7.96 times 10 to the 10th electrons. The remaining two values, total atoms and ratio of excess electrons to atoms, are fairly self-explanatory and are determined by the functions to the right of the equal sign. Here is my Glossgroup code that aims to verify the calculations made in the last slide. First, the constants are defined and used to find the force of gravity. Next, I created my distance vector and implemented the tape charge, total atom, excess electron, and ratio equations aforementioned. On the right, I imported the electric field function from Lab 0 to help finalize the electric force vectors and create arrow objects. When programming the virtual model, I decided to make tape A centered at the origin and tape B 0.028 meters away in the positive y direction. Here's the code again. If you want to take a look in further detail, it will be linked in the description of this video. When this is run, you can see the blue ball represents tape A and the red tape B. The orange arrows represent the electric force applied by either tape on each other. The green arrow symbolizes the gravitational force experienced by the floating tape. Located in the text box below are important values in this experiment that verify the math shown in the PowerPoint. So, what if electrons were positive and protons were negative? Well, within this experiment, nothing would change. Like charges still repel and opposite charges still attract, so the numerical answers would be the same excluding a sign change. In addition, we are mainly analyzing magnitude, so sign is not important. Why is it important to limit contact with charged tapes, and how can touching them affect the experiment? When my hand or another neutral object touches the charged tape, there is an exchange of electrons that eventually leads to a neutral equilibrium. If the two tapes become neutral, the repulsion between them would not be strong, and the distance needed to complete this lab would be non-existent. Thank you.